Welcome to the lesson 3 video. We've got our warm-up questions here first. So activity 1, you should substitute the correct value. So tell me what that variable should equal. Activity 2 is answer each question. They go kind of back and forth between if the variable equals this specific number, what does this expression equal, or problems like activity 1. So pause the video, work out those problems, unpause it, and see how you did. So number 1, x plus 7 equals 25. That means that x needs to be 18 because 18 plus 7 equals 25. You should get 82 for B. You should get 6 for Z, 63 for 4, 100 for 5, and 195 for 6. Activity 2, if the value of n is 7, 7 plus 1 is 8. Okay, what should x equal? Well, 2 plus 6 equals 8. So I should actually be saying x equals 8 here. Number 3, if y is 18, 4 plus 18 is 22. If n equals 17, 17 minus 8 is going to be 9. If z equals 25, z divided by 5 is 5. If we have m divided by 9 and m is 81, 81 divided by 9 is also 9. Today we're going to be talking about ratios and describing relationships. Part to part and part to whole. There's going to be a lot of things I scroll past, but remember that's kind of in your OneNote. That's something that for you to look at if you need to kind of read through the explanation of each step. But I'm going to basically be saying all of those things just in one place instead. So for this first one, we're going to look at two cars. For every one lap that car 1 does, car 2 does 4. So for every 2 laps, car 1 does, car 2 does 8. 3 to 12, 4 to 16, 5 to 20. There is a pattern here where we're taking that first one times 4 to get the number of laps for car 2. So we could, to use a fancy word, extrapolate. We could figure out what how many laps car 2 has done if car 1 has done 10 laps. I would just take 10 times 4, and car 2 would have done 40 laps. Okay, that's called our vertical strategy, where we're looking at a table of numbers, and we're comparing the numbers vertically. Okay, meaning up and down. We're comparing these two numbers, those two, and so on. That's why it's vertical. So we could write this 3 different ways. They're all going to be the same ratio, and they're all going to be read as 1 to 4. We're comparing two numbers, 1 to 4, 1 colon 4, meaning 1 to 4. That's how we actually would read it. Or we could write it as a fraction, 1 to 4. We're comparing these numbers. It is a ratio. It is two numbers always. All right? So what is a ratio? It is a comparison of two. I'm going to put a box and highlight it and draw some arrows to it. It's a comparison of two numbers. The reason I did all this stuff with the highlighter and the arrow and all that stuff is it has to be two numbers. Okay, you're always comparing one number to another number. You cannot just get like 5 as an answer. A ratio is always two numbers. Okay, we can write them 3 different ways. We can write a ratio as 1 to 4, 1 to 4, or 1 to 4. They're all read the same, but these numbers aren't always going to be 1s and 4s. Okay, they could be any number. So I'm going to write it out with 2 variables. So I could say A to B, A to B, A to B. Any number could go in for A, any number can go in for B. Okay, that's just kind of how it is. So there are kind of 2 parts. We have a part to part or a part to whole. So a part to part is if I take a piece of the entire thing. So in this case, squares. So there are 4 squares. If I take a different piece, in this case circles, there are 2 circles. Be 4 to 2, or 4 to 2, or 4 to 2. Now, with ratios, you can simplify them, and you should. Okay, 4 divided by 2, I know is just 2, but remember, a ratio has to be a comparison of 2 numbers. So I'm going to write it as 2 to 1. I simplified the fraction first because I personally think that's the easiest, but it's the exact same steps to figure out the other ones because it's the same ratio. Okay, it's just written slightly differently. So the ratio of squares to circles is 2 to 1. So for every 2 squares, that means there's 1 circle. A part to whole relationship is like triangles to total shapes. There are 3 triangles to, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 total shapes. So I could write them all like this. But I need to simplify. 3 to 9, that simplifies to 1/3. So I have 1 to 3, and 1, oops. Almost went with the colon 1 twice. And 1 to 3. Okay, so for these, like I had divided by 2 on top and bottom. For here, I divided by 3 on top and bottom. It's the exact same rules for simplifying fractions as it is for simplifying ratios. The only exception is in a number like this. We have to have a comparison of 2 numbers, so it would be 2 over 1, not just 2. Alright, so a fraction always shows a part-to-whole relationship, and a ratio sometimes shows a part-to-whole relationship. A fraction never shows a part-to-part relationship, and a ratio sometimes shows a part-to-part relationship. These things right here are kind of, I can see where they're going to be very confusing, because we can write a ratio as a fraction. You can always write a ratio as a fraction. I'm going to put as a fraction in quotation marks. So if you see something like 1/4 that looks like a fraction, but depending on the context of the problem, it might be a ratio. So it might be a part-to-part relationship, even though fractions are never supposed to show a part-to-part relationship. So we're going to have a couple word problems. So the first one, if there are 12 girls in a class of 26 students, what is the ratio of girls to total students in the class? So first, it's really important to notice which side of the word to the things go on. Okay, so for this one, girls comes first. There are 12 girls, and we know there are 26 total students. So 12 to 26, which I'm going to write as a fraction. Oops. Helps if you write the right numbers. And then I need to simplify this. I know both of those numbers can be divided by 2. Okay, 12 divided by 2 is 6. 26 divided by 2 is 13. So the ratio of girls to total students is 6 to 13. Alright, so they're going to break this down kind of step by step in there, where they put number of girls first, then number in the class second. But notice that in our final answer, we do not have any words. Okay, it's just that ratio. Now, they didn't simplify, but I'm telling you that you need to always simplify your ratios. Now, they're going to change the same question just a little bit. Instead of being girls to total students, it's girls to boys in the class. So we're going to say that the total number of students minus the number of girls is the number of boys. So we can find out there are 14 boys in the class. If we do that, the ratio of girls to boys would be 12 girls to 14 boys, which can simplify, if I divided both of these by 2 again, to 6 to 7. So we would say that for every 6 girls in class, there are 7 boys. That's the ratio of girls to boys is 6 to 7. And again, we're going to break down step by step, do the exact same thing we did, so I'm just going to scroll past that real quick. Now we're going to make some comparisons with a set of cards. So in general, there are 4 suits, they're called. There are hearts, diamonds, spades, and clubs. So everyone hopefully knows that hearts look like that, roughly. I'm really not that great of an artist, so judge me if you want to, but please don't judge me too harshly. Diamonds, you would think that I would be able to draw a diamond better, but apparently right now I'm struggling. Diamonds are going to look like that. Spades, these are ones that I'm really bad at drawing. And then clubs look something like that. I drew them in these specific colors because in the future you might be referring to red cards and black cards. Hearts and diamonds are the red cards. Spades and clubs are the black cards. All right, so there are a lot of different ways we can make comparisons. So if we want to make a ratio with just these 5 cards, ratio of cards with hearts to cards with diamonds. So hearts to diamonds, there are 2 hearts, 2. There's only one diamond, so our ratio has to be 2 to 1. Now, if I flip this around and said ratio of diamonds to hearts, that's the exact same numbers, but a completely different ratio. There's 1 card with diamonds to 2 cards with hearts. These are not the same. Okay, they tell us the same information, but they're not the same ratio. Okay, they just kind of highlighted those things. So diamonds to cards with clubs is our next question. So there's 1 card with diamonds and then 2 cards that have clubs. So 1 card with diamonds to 2 cards with clubs. I don't care how many clubs are on the card. It's just number of cards with the clubs. Okay, and then hearts to cards with clubs. 2 hearts, 2 clubs, 2 to 2, but that should be 1 to 1. Okay, for every card with a heart, there's a card with a club. Remember to always simplify our ratios. Now, if we want to do a ratio of cards with hearts to all of the cards, there are 2 cards with hearts, which we've established, to 5 total cards. Okay, total cards counts those hearts again. All right, it's when it says total cards, it means every single card, even if you've already counted them once. Ratio of cards with spades to all the cards. None of these have spades, so 0 to there are 5 cards. Ratio always has to have 2 numbers, even if one of the numbers is 0. All right, so there are 5 problems here. Quick, I'm going to have you pause the video and try them out. I'll go through number 1 first so you can kind of see what to expect, and then you'll do 2 through 5. So number 1, Aaron makes light blue paint by mixing 2 quarts of blue paint with 1 quart of white paint. What's the ratio of blue paint to white paint? Okay, so blue to white, so the ratio of blue, I'm just going to put the colors, to white can be written as there are 2 quarts, and then you can fill in with 2 or colon, either is fine. To 1 quart of white paint is the general thing, but they have 3 blanks here. So I'm actually going to have you write all 3. So you could say 2 to 1, 2 to 1, or 2 to 1. And then this relationship, is it a part to part or a part to whole? This is a part to part because I'm making a different color. I use some blue, I use some white. The some blue and the some white are going to be the 2 different parts. So go ahead, pause the video, do 2 through 5. Come unpause it and see how you did. So for this next one, ratio of cats to total pets. I should probably put the word total there. Okay, that's 14 to 35. Okay, I could simplify that. I'm going to write them all out first and then simplify it so you can see maybe if you did the rest right without simplifying. Okay, I could have written this. Those are both divisible by 7. So I could have had 2 to 5, 2 to 5, or 2/5. This is a part to whole relationship because they have 35 total pets. If you see the word total, that's going to be part to whole every time. So now there are cats and dogs. So cats to dogs, 14 to 15. This one cannot simplify. So you have 14 to 15, and that's part to part. Now we've got 35 green marbles out of 60 in a bag. We're talking ratio of green to total marbles. Again, this one's going to be able to simplify, so I'm going to write it without simplifying first and then come back and simplify. Okay, if I simplify, those are all divisible by 5. So I'm going to have 7 to 12, 7 to 12, and 7 to 12. This is a part to whole. It said total marbles. Now we're comparing green marbles to blue marbles. 35 to 10, 35 to 10, 35 to 10. But these simplify also. They're all divisible by 5 again. So 7 to 2, 7 to 2, or 7 to 2. This is part to part. All right. For the problem solving, we're going to be able to solve word problems by identifying and writing ratios in tables. So this is kind of the entire process. We're going to set up a table like this in pretty much every problem. All right. So I'm going to do number 1 with you, and then again, pause video, do 2 through 5. But the process is what we just did for the entire first part of this lesson. So it says the ratio of boys to girls in the class is 2 to 4. If there are 20 girls in the class, how many boys are there? So what we do is we take this ratio. We know it is boys to girls, 2 boys, 4 girls. So I'm just going to count by this number going across on the top and that number going across on the bottom. So I could have 2 boys, 4, 6, 8, 10, 12, 14. 4 girls, add 4 is 8, 12, 16, 20, 24, 28. So now it's asking if there are 20 girls, how many boys are in the class? So we go into the list of girls to 20, and then the number above it tells me the number of boys. So there are 10 boys in class. And that's how we can do that with these tables. So I'm going to have you pause the video, do 2 through 5, and then come back and see how you did. All right, so after you've unpaused, you should see the number of pigs. We know that pigs to goats is 1 to 5. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 5, 10, 15, 20, 25, 30, 35. I filled out the entire table before I even read the rest of the question. It says if there are 15 goats, so I find goats, 15. Tells me there are 3 pigs. Ratio of pigs to animals. This is total animals. Is 1 to 10. Excuse me. Number of pigs, so 1. I'm again counting just by 1. And then for number of animals, I count by tens. So if the farm has 50 animals, number of animals is 50. How many pigs are there? There are 5 pigs. Number 4, the ratio of Mexican restaurants to hamburger restaurants in town is 2 to 3. So 2 Mexican restaurants, 3 hamburger restaurants. Count by 2 on the top. Count by 3 on the bottom. If there are 12 Mexican restaurants in town, number of Mexican restaurants, 12. This time we were looking at the top number to figure out the bottom number, so it's important to actually pay attention to where you put your numbers. How many burger restaurants are there? There are 18 hamburger restaurants. And number 5, the ratio of ice cream to milk in a milkshake is 2 cups ice cream to 1 cup milk. So count by 2s on top. Count by 1s on bottom. The restaurant is 18 cups of ice cream. Look at ice cream, 18. How much milk did they use? That's going to be 9. They used 9 cups of milk. Now for all of these, I filled out the entire table. I want you to fill out the entire table. Like these ones, if you're paying attention, you're like, oh, I just need to get to 15. And you could have stopped there. But I want you to fill out the entire table because there might be a time where I ask you multiple questions with the same table. So it's just a good habit to fill out the entire thing. All right. Make sure you finish Lesson 3 homework in OneNote, and I hope everybody has a great day.